Again, a disproportionation reaction.
Yes, sir.
So what mole of sodium nitrate, what mole of nitrogen? What is the value of X, what is the value of Y, what is the value of Z? Is it okay? So if 5 nitrite will give me 3 sodium nitrate, 1 nitrogen plus sodium oxide. So 2 moles of sodium nitrate will react with 1 mole of sulfuric acid to give you 1 mole of sodium sulfate and 2 moles of nitric acid. Because this acid, proton is an acidic proton. This hydrogen is an acidic hydrogen. So it will give you another mole of nitric acid to react with this. The second method is your Oswald's process. We have discussed this earlier. You have balanced the reaction. That when you heat, you burn ammonia in presence of oxygen. In presence of platinum as a catalyst, you get nitric oxide. In absence of catalyst, it will give you nitrogen plus water. Lead, when you react with nitric acid, will give you lead nitrate plus water. In presence of oxygen is required.
Yes, sir.
And the dilute nitric acid will convert into nitric oxide. The product of dilute nitric acid normally gives nitric oxide as a product.
Yes.
So, if you balance this reaction, lead goes to lead 2 plus 2 electron, nitrate ion 5 plus goes to NO 2 plus 3 electron. So 3 lead,
4 HN.
I need 4 HNO3 to give 2 moles of nitric oxide and 2 moles of water. Only in case of mercury, you will get mercurous nitrate, not mercuric nitrate. Remember that mercury will give HgNO3 twice and not HgNO3 twice. With dilute nitric acid, it will give mercurous nitrate and not mercuric nitrate. You have to remember that part very carefully. Iron and zinc, when you react with dilute nitric acid, the product of nitric acid is nitrous oxide and not nitric oxide. So copper, iron, lead, silver, mercury, they give you nitric oxide as a product. But iron and zinc will give you nitrous oxide as a product. Okay? So write the equation zinc plus, write this equation, zinc plus nitric acid, dilute nitric acid gives you zinc nitrate, N2O plus water. How many electrons change? Nitric acid to nitrous oxide?
8 electrons.
8 electrons.
Sir, N2
8 electron chain.
Yes, sir.
Because there are two nitrogen.
Yes, sir.
So nitrate to nitrous oxide is a 8 electron chain. So I require 4 moles of zinc
4 chains.
to form N2O. So 2 moles of this with concentrated nitric acid. Okay, cold, very dilute nitric acid. So zinc plus nitric acid. If you take a cold, very dilute nitric acid gets converted to ammonia. And ammonia reacts with nitric acid to give you ammonium nitrate. And that is why the product is ammonium nitrate. Actually, the nitrate ion is converted into ammonia. It's an 8 electron change. Ammonia being base, so it cannot exist as ammonia in acid medium, so it forms a salt ammonium nitrate. So the zinc will, iron, tin and zinc will convert nitrate ion to ammonium nitrate. Concentrated nitric acid. The product is always nitrogen dioxide. So you have no problem with concentrated nitric acid. It's a 1 electron change. So copper, zinc, lead, silver, iron, mercury will give me copper nitrate, zinc nitrate, lead nitrate, silver nitrate, ferric nitrate. And mercuric nitrate. And always the product is your nitrogen dioxide. Okay? Now write one reaction. Iron plus concentrated nitric acid. Do this one. Quickly. Fast, very fast. Iron plus concentrated nitric acid gives you ferric nitrate, nitrogen dioxide plus water. Because iron to ferric is a 3 electron chain. And nitric acid to nitrogen dioxide is a 1 electron chain. But I need additional 3 nitrate.
Yes.
So I need 6 moles of nitric acid per mole of iron. H2S goes to sulfur, but sulfur goes to sulfuric acid. Why H2S does not go to sulfuric acid? Give me the answer. Why H2S goes to sulfur, but sulfur goes to sulfuric acid? Because H2S is a reducing in nature. H2S is a reducing acid. So it resists to undergo oxidation. So it can go up to sulfur. But sulfur is not a reducing in nature, so it can go to the higher oxidation state more readily than H2S. So H2S H2S to sulfur is a 2 electron change. Nitrate to nitrogen dioxide is a 1 electron change. So per mole of H2S I need 2 moles of nitric acid to get sulfur plus 2 moles of nitrogen dioxide plus 2 moles of water. Okay, now,
Excuse me, sir.
yes,
So while H2S gets converted to H2SO4, so S will get converted from 2 minus to 6 plus. So sir, what is the problem means? It can get, it is, since it is reducing in nature, it will have a tendency to oxidize itself. So it will get, means,
it
why
will,
won't it get converted?
because it is reducing in nature. So it does not get oxidized to a very high oxidation state. It is oxidized, but not to a very high oxidation state unless you constantly boil it with concentrated nitric acid. The immediate product will be sulfur and not sulfuric acid. Potassium iodide. Iodide goes to iodine, but iodine goes to iodic acid. Same reason, that iodide being a reducing agent, so it does not want to go to a very high oxidation state. It prevents to go to a high oxidation state. It goes up to iodine. But when you start with iodine, you go to HiO3 plus 5 oxidation state. So it goes, it oxidizes, but it does not oxidize to a very high oxidation state because of its reducing nature.
Sir, how
Yes?
does change in concentration of HNO3 affect its reactivity?
Which one?
Change in concentration
Yes.
since the past
Yes. Lower the acidity, the electron transfer is easier. When you lower the acidity, you get N2O, 8 electron change. You get ammonia, 8 electron change. When you use the high acidity, you get 1 electron change to nitrogen dioxide. So the lower the acidity, the electron transfer is more favored.
Yes.
P4 plus concentrated nitric acid gives you H3PO4, nitrogen dioxide plus water. How many moles of nitric acid I require? 0 going to plus 5. How many electron change? 20 electron change.
Yes.
So I need 20 moles of nitric acid. Gives me 20 moles of nitrogen dioxide and 10 moles of water. Each phosphorus is undergoing 5 electron change. There are 4 phosphorus. So the total electron change is 20. For nitrogen, the electron change is 1. So I need 20 moles of nitric acid. Quickly balance this reaction. Tell me again, what is the... How many moles of nitric acid I require?
36.
So for carbon, there is a 3 electron change for each carbon. There are 12 carbons. So 12 into 3, 36. And that is why 36 nitric acid.
Yes. Yes.
Okay. Now, Devonder's alloy is copper 50%, aluminium 45%, and zinc 5%. This alloy converts nitrate to ammonia in which medium? If you take Devonder's alloy and add alkali and put nitrate on and boil, you get ammonia gas. So the nitrate ion can be converted to ammonia by Devonder's alloy in alkaline condition. Nitrate ion and nitrite ion both give ammonia by Devada's alloy, and both give brown ring test. Remember, the nitrite and the nitrate both will give brown ring test. Both will convert, nitrite will convert to ammonia, nitrate will convert to ammonia by the action of Devada's alloy. Which is responsible? This and this. They are amphoteric metal. They react, convert nitrate to ammonia, nitrite to ammonia. Not copper. Copper does not take part. It's a part of an alloy, but it is the metal which converts nitrate to ammonia, is aluminium or zinc. What is the product formed by zinc and by aluminium in this reaction? Zinc forms zincation and aluminium forms alumination. Ammonia. Take ammonium salt and react with sodium hydroxide. If you heat, you get ammonia gas. So if I take ammonium chloride plus sodium hydroxide, I get ammonia, sodium chloride and water. This is number one method. Second, ionic nitride, when you add water at room temperature, you get ammonia gas and metal. So if I take aluminium nitride and add water, I get 3 moles of water per mole of aluminium nitride. I will get aluminium hydroxide and 1 mole of ammonia. 3 moles of water gives me 3 proton plus 3 hydroxide ion. And aluminium 3 plus 3 hydroxide ion gives me aluminium hydroxide. And the nitride ion plus 3 proton gives me ammonia. That is how I get aluminum hydroxide and ammonia. So any ionic nitride, I have given you earlier ionic nitride, lithium, magnesium, calcium, barium, aluminium. When you add water at room temperature, it will give you ammonia gas and metal hydroxide will form. How it forms? Now you can see that ammonia goes to NF3. How many electrons change?
6 electrons.
Out of these 6 fluoride, 3 fluorides are combining with this nitrogen.
Yes.
And 3 fluorides combining with a 3H plus to form 3HF. And 3HF plus 3 ammonia gives you 3 ammonium fluoride. Six chloride. So here the 2 moles of ammonia getting oxidized to nitrogen, releasing 6 electrons plus 6 proton. 3 chlorine accepts 6 electrons to convert 6 chloride ion. 6 chloride plus 6 proton to give you 6 HCl. And out of 8 ammonia, 6 ammonia it is there to combine with HCl to form 6 ammonium chloride. You have excess of chlorine. When ammonia is reacted with excess of chlorine, you get NCl3 plus HCl. And NCl3 is a very explosive substance. Ammonia, when you react with sodium hypochlorite, ammonia with sodium hypochlorite will give you chloramine plus sodium hydroxide. Chloramine reacts with another mole of ammonia to give you hydrazine plus HCl. HCl reacts with sodium hydroxide to give you sodium chloride plus water. So, if I write 2 moles of ammonia with 1 mole of sodium hypochlorite, I get hydrazine, sodium chloride plus water. Now in one step I can write this, but then you don't get the idea of how it is working. So I split this reaction into stepwise manner. K2HgI4 in alkaline medium is called S+ reagent. It gives you, so alkaline solution of K2HgI4 is an S+ reagent, not an aqua solution. Alkaline solution gives you iodide of Milan's base. The iodide of Milan's base is orange-yellow color. You can get the color or a precipitate depending upon the ammonia concentration. If the ammonia concentration is high, you get precipitate. If ammonia concentration is less, you get the solution color. No precipitate. Ammonia with excess of iodine, you get Ni3 dot NH3. Ammonia with excess of iodine gives you not Ni3. Ni3 does not exist. It exists in the form of an adduct with ammonia. Ni3 does not exist as free. It exists in the form of an adduct with ammonia. Calcium chloride with ammonia forms an adduct with calcium chloride dot 8 ammonia. So 8 moles of ammonia reacts with calcium chloride to form an adduct of calcium chloride dot 8 ammonia. Ammonia can be dried over calcium oxide because calcium oxide is a basic oxide and ammonia is a base, so it will not react. So it will remove the molecule of water from the ammonia gas and make the ammonia gas dry. Phosphorus exists 3 variety of allotropes. Actually, minimum 6. It has more than 6. That is the white phosphorus, red phosphorus, and the black phosphorus. These 3 are the main varieties of phosphorus allotropes. The white phosphorus it is the most common variety of phosphorus. It is the most reactive form of phosphorus due to acute angular strain, that is 60 degrees. It is the acute angular strain makes it most reactive. White phosphorus is a soft waxy solid, metastable, with a garlic odor. You have seen ozone has a fishy smell, and hydride of phosphorus has a rotten fish smell. Phosphorus has a garlic odor. It ignites in air. It burns in air if it is heated above 35 degrees Celsius. Hence kept under water. It is insoluble in water but soluble in carbon disulfide and benzene. It is soluble in carbon disulfide and benzene. It is highly poisonous, and the person working with the white phosphorus develops a disease called fuzzy jaw. So people working with white phosphorus develops a disease called fuzzy jaw, which breaks the jaw bones. So it is highly poisonous. White phosphorus reacts with sodium hydroxide to form phosphine and 3 moles of sodium hypophosphite. Phosphorus, white phosphorus burns in chlorine. That is why the red phosphorus is used to prepare PCl3, but not white phosphorus. For all other purposes, all reactions of phosphorus are from white phosphorus, except the halogen chlorine. White phosphorus, when it is heated to 250 degrees Celsius, it changes to red powder, that is red phosphorus, which is polymeric in nature, which is a polymer. So the red phosphorus is a polymer. Because it is a polymer, so it is less reactive. And the angle is now increased to 101 degree. So the acute angular strain has relieved. In white phosphorus, there was acute angular strain of 60 degree. Now the angle has widened to 101 degree. So the angular strain has disappeared and it has become a polymer. Since you have to be in a polymer, you have to break a large number of bonds, so the molecule becomes less reactive than white phosphorus. White phosphorus, melting point is 44 degrees Celsius, whereas for red phosphorus, it melts at 600 degrees Celsius. So you see the difference. P4, white phosphorus exists as an individual P4 molecule. But in red phosphorus, you have a large number of P4 molecules attached to each other and giving rise to a polymer. And the polymer is always less reactive than a monomer. Red phosphorus ignites in air at only at 400 degrees. If you heat it to 400 degrees, it will react, it will burn in oxygen. But red phosphorus is insoluble in water, carbon disulfide, and benzene. Unlike white phosphorus, which is soluble in carbon disulfide and benzene, red phosphorus is insoluble. Red phosphorus is non-toxic. It is not poisonous substance. Red phosphorus does not react with sodium hydroxide. White phosphorus reacts with sodium hydroxide to give you phosphine and sodium hypophosphite. Red phosphorus does not react with sodium hydroxide. Red phosphorus. Red phosphorus is used in match industry. White phosphorus, if you heat it to high temperature and high pressure, then you get black phosphorus, which is thermodynamically more stable. So a few years back, 3-4 years back, they asked this question: which is the most stable allotrope of phosphorus? And it is the black phosphorus which is the most stable. It is a polymer. Black phosphorus is more polymeric in nature than red phosphorus. And the white phosphorus is thermodynamically least stable. That is why I have mentioned white phosphorus as a soft, waxy, metastable solid. It has a layer structure like graphite. It is semiconducting and chemically inert. Okay?